Welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast. I'm your host, Dean Phillips, and I have an outstanding guest here today. I have with me Bob Roth, who is the president and also the CEO of Roman Manufacturing, and he is also the vice president of the American Welding Society. Welcome, Bob.
Dean, it's great to be with you.
Thank you so much for taking time out of your schedule. So right off the bat, what is your big takeaway for 5 years from now in our manufacturing organizations as a whole?
Well, first and foremost, 5 years from now, manufacturing here in the United States, North America, is going to be stronger than it's ever been. So I'm very bullish on it. And I also think that technology, automation specifically, will just continue to evolve its way into today's manufacturer. Big, small, medium size, doesn't matter. Automation is going to become a growing key to what we're doing.
Right. And so being the president of Roman Manufacturing, how are you addressing some of these automation needs as a whole?
A great question. So it's kind of interesting. In our business, we actually build a component that is a part of a larger automation system. So from a who we serve point of view, we've always been geared towards factory automation. The interesting thing, though, is in our own manufacturing, because again, it's a low volume, discreetly designed product. We were pretty manual, and so we see it and what our customers are doing for their customers. But in our own operations, I would have put us kind of maybe behind the curve a little bit. And so as we've watched robotics become more user-friendly and the cost just keeps driving down as one example, of course, the first place that we really saw the widespread application in our own business of automation would have been in CNC machining. And I look at the advances that have been made in the machinery that we've bought over the last 30 years, and it's really pretty remarkable what a machine can do today that 30 years ago you wouldn't even thought of, and how the price of that capacity has just dropped dramatically. So what you would have spent $1 million on a decade ago, today you can get for $350,000.
Yeah, I agree with that 100%. I think the availability and affordability of products has really changed the scope of what's possible.
Absolutely.
So tell me about your background. Tell me how you got involved in manufacturing.
I have to give a lot of the credit to that to my father. My father is an engineer by training. Worked in the industry that I'm in today. Ultimately, was the co-founder of Roman Manufacturing, and in my education, I went to a school that was once upon a time called General Motors Institute in wonderful Flint, Michigan, and today's called Kettering University. Back when I attended, the school was literally owned by General Motors Corporation, and so it was, it might still today be the only full-time cooperative education a school of its kind. So you had a corporate sponsor as well as going to school. So you would spend 3 months at school, then go to your corporate sponsor. My case was the Hydra-matic Division of General Motors, and work in the plant in the factory. And then this went on for 5 years: 3 months at school, 3 months at work. And so I've always just again been interested in how things are made and how things go together. Worked for GM for a few years, and then had the opportunity to come home to our family business. And so it's really, from as long as I can remember, there's always been this kind of exposure to and interest in how things are made.
I think that everybody I ever talked to in manufacturing that's still in it and has thrived in it finds that there's something, that key search, constantly working to improve, constantly searching to educate yourself more. And I think that's true for everybody I ever run across in manufacturing as a whole.
Yeah, I've had a very similar experience. Just as a kind of funny little sidelight in that learning stuff, my dad had a wood shop, and so I was woodworking at a young age, and was making wooden toys. And my mom would bring them to the church bazaar or whatever, and a lady that owned a gift shop had seen my toys and wanted me to sell some of my toys through her store, and so I made up a whole batch of toys, and my dad was driving me to drop the toys off, and he asked me about, well, how did you price them? And I said, well, I got a couple bucks in wood, and so I'm gonna, I got $2 in wood, I'm gonna charge $4. And he said, well, he says, we need to think about this a little bit. He says, all that equipment you've been using, well, that's my equipment, and you've been using it for free. But if you had your own factory, right, you'd have to pay for that equipment. So you got to think about depreciation. What about that electric bill? I'm paying that electric bill for you, but if you had your own factory, you'd have to pay the electric bill. And what about your time? How much is that worth? And so it's literally at about 12 years old, my dad was going through building a profit and loss statement and let me understand that it wasn't just what's the material cost and add a couple bucks and we're good.
Right. And I think that's something that we've lost a lot in schools and in just as a whole. I agree that you have to have a way of understanding those things from a grassroots level and seeing, hey, what does this really mean? Because it's sad to say, there are people out there today doing exactly what you just said.
Right. Yeah, and they wonder why can't I compete? Why can't I survive? And again, they really they don't understand their cost structures. They don't have a way to analyze where the competition is at and how are they going about it. And again, it ties back into if you're in a position where you might not find yourself being the market leader or being as competitive as you want, what can you change? And again, in manufacturing, it's this idea of automation that allows us to become more consistent and drive out costs. And again, I think that why I'm bullish on manufacturing in North America is I think this idea of chasing cheap labor has kind of run its course in many ways. And all of a sudden, the cost of transportation, how do you get something across an ocean, the cost or risks associated when governments go at each other with tariffs, well, how do you mitigate those things? Well, if you can manufacture and serve your region, so you kind of got to think globally, but act regionally. And we as a part of our business, have a foundry, and we've been taking on work that once upon a time our customers were sourcing overseas, but have found that the quality, the speed to market that we can provide because we're delivering regionally as opposed to globally for them and it's not just about what's the piece price. So there's plenty of ways to be competitive in a very global market.
Right. And you talked a little bit earlier about automation. Where do you see automation taking us?
Again, I think that and this is the tough part. I think that the factory, and especially when you start to talk about middle market and small companies, is going to become just in general, as the trend has been, less labor intensive. And so the idea that, I can go to the local factory, come on out of high school and kind of get in there and put in my time and work hard. And, 35 years later, I can retire from there. I think those days are largely gone for that type of work. So now it's the type of skill set that says, do I know how to program this type of equipment? Do I know how to maintain this type of equipment? Do I understand workflows? So now it's a different set of skills that one needs to bring as the number of employees that are physically doing the work goes down. And again, in that whole cost curve of, today, again, if you look at robotics, and you don't need the level of competency of coding once upon a time to make a robot work in an industrial application. They make the programming and the software far more intuitive. A lot of times you can, with smaller pick and place type robots, you can literally, go to the control and press teach, and then physically take the robot arm and move it while it's in this teaching mode. And that's how you program it. So that's where I think it's going. But we also have to recognize that there's going to be this dislocation, and that's never fun, and it's never easy if you're one of the people being dislocated because your skill sets don't align with where manufacturing's going.
Right. And there's no question about that some of that is going to have to happen in manufacturing. We've got a lot of people that we need to help develop those skills. And do you see that being more of an on-the-job training thing, or do you think that it's something that we would do where we send people, okay, we're going to send you to this school to be retrained on as a coder or to work in these different technologies? Do you see that?
I actually think it's in some ways going back to the future a little bit in if you looked at the skilled trades model of how did you become an electrician? How do you become a pipe fitter, a millwright, a carpenter? Is that combination of there is a school, classroom setting component to learning that. There are math skills that one needs. There are communication skills that needs, and the academic setting is great. But then it's in the field practicing, doing the work as an apprentice. And so I really do think it's this apprentice model is going to be really important to this transition, that it's not just purely 100% on the job or 100% in the classroom. It's this combination, and we've got to communicate with young people about the value of these jobs, and again, nothing against 4-year degrees. I've got one, but it's not the only way to a career success. And I think if we did ourselves a disservice, it was not embracing the trades, if you will, and apprenticeship as a learning model. And I think we've got some catch up to do in that regard.
That's for sure. You can't book train troubleshooting. I don't.
Correct. You got to experience it, and that's that apprenticeship model where I've learned these things. I have these kind of book skills, if you will, but I've got with a master looking over my work, that I'm actually practicing it and doing it and experiencing it and building that ability. Problem solving is not a book learned skill. It's taking base skills and then putting them together on a unique situation. And the jobs in manufacturing are going to be around that type of work, as opposed to kind of the, unfortunately, more mind-numbing work of, I come in and I put these lug nuts on, and I put those lug nuts on for 30 years. And that's all they want of me is just, my back and my hands. They don't want my brain. Well, in my manufacturing company, I need your brains.
Right. Yeah, that's for sure. Today, you have to be able to think on your feet. I think in every aspect in every job, you want them developing ideas that help to improve the company and improve our overall production. It's something that we need to have.
Absolutely.
Do you think from working with the American Welding Society, AWS, do you see more of a focus now on things like virtual reality, smart manufacturing.
Yeah, and not only as it's physically applied in the factory floor and the production of products, but we're actually using it at the American Welding Society as a tool to attract young people to the profession. Mm-hmm. We have at the American Welding Society a large semi truck and trailer that goes around the country, literally to like the 4-H fairs and events like that, where we set up inside the trailer is a virtual welding system, and so kids can physically experience what it's like to try to make a weld. And using if it wasn't for virtual reality, we'd never be able to do that on the scale that we do. And again, kind of in the the fact that kids love games and gaming and things like that. During our 100th anniversary year at the American Welding Society, every place that the trailer's at, the high scorer of the day gets a $1,000 scholarship that the American Welding Society provides should they choose to pursue a career in welding. And so, yeah, it's really interesting how you can use virtual reality not only in the factory for simulation before we move to production, if you will, but how we can use it to attract talent.
Yeah, I think you hit it on the head. Is the first thing we have to do is we have to get people interested in manufacturing again, and we have to let them know. And
I mean, we got, dark, dirty, and dangerous was kind of, the 3 Ds around manufacturing. And that's not what today's manufacturing environment is. They are anything but, dark, dirty, and dangerous. And so we've got to put a lot of effort as manufacturers into promoting what the reality is about what we're doing and the skills that we need. And if we don't take the effort to create that excitement, and that's really why I'm happy. And the American Welding Society, I know, is not unique in that sense. There's other professional societies that are doing the same types of things to say, hey, we got to get the story out about what's going on in manufacturing, and it's important, and it's a great career. And the opportunities, once you're in, you're not stuck in that job for the rest of your, 30, 40-year working career, that there are many places that you can go within a manufacturing company that you might never even imagined when you first entered employment.
That's a great point. It's something that we need to look at, and that we need to get schools encouraged to promote also.
Absolutely.
That's the difficult part. I think we've shunned people for too long and pushed them away from it. We need to encourage them that this is an option, and it's a well-paying option. I think too often we think, oh, well, you only go that route if you have no other options, and that you can't be you couldn't achieve through the other avenues. And I think that's the wrong impression to send, because there's a lot of good paying jobs in manufacturing, and there's great opportunities here to really change the future across the board, and make a difference.
Oh yeah. And I think specific, manufacturing and kind of parallel to that in the construction industry, if you talk about business ownership, who are the business owners, right? And if that's ultimately somebody's aspiration to become a business owner, and you look in manufacturing and you look in construction, you don't have to dig too far in pick a company that's where they are. They're a manufacturer. They're in the construction trades. And what you find is that those companies were started largely by tradespeople and engineers, right? And those very same people that started those companies, I think if you could have met them in their high school years, their college years, or even early working years and said, "Are you going to be a business owner?" And it wouldn't even been in their thought process. Yet they became a business owner, and it was on that base skill that they had learned and they knew so well, that allowed them to say, "Hey, I think I got a better idea. I'm going to start a company to do this." And so if business ownership is of interest, I would make an argument that a pathway in manufacturing to business ownership, or a pathway in construction to business ownership, is more likely through the trades than it is a 4-year college degree.
Yeah. I especially nowadays with how things are. If you look at smart manufacturing, the opportunities there in smart manufacturing. I've run across more companies now that use drones for confined space inspections, for troubleshooting machines going up on top, so that you're not putting an individual at risk to do this. And those kinds of opportunities are there. You don't have to have a 4-year degree to be a drone pilot or own a drone company. You don't need that. And you can make very good money doing those kinds of things in manufacturing. Do you see other opportunities like that coming out with additive manufacturing and some of the other processes that we see, like the Internet of Things? Where do you see all of that taking us, especially from the AWS side and from your personal standpoint, your company?
Yeah. And I was kind of thinking about that in getting prepared for our talk, our discussion today. And sometimes I will admit that I get a little bit pushed off by, sometimes I think the titles of things get a little bit ahead of maybe the reality, so Industry 4.0 and AI is going to be everything. And I say, well, okay, we all evolve at our own in different paces. But then when I actually thought about the application, and so you touched on additive manufacturing. Today we have in our engineering department a handful of desktop 3D printers, and we're not using those specific printers for production, but allow some quick and easy modeling to happen for our engineers, that they can actually play with parts, because even as powerful as our 3D CAD is and things like that, there's still things when it comes to, for example, putting wiring or hosing into a machine system that is still today very difficult to do in a low volume applications like the products we build in the CAD system. But quickly printing out some component parts and then physically trying to put them together, the bridge between engineering and actual production, we can close that gap because there's a physicality to it, and you can do that so cheaply and so fast today. So that's one application. Then in our foundry, we got approached by the Department of Energy for one of its particulate accelerators, and they were machining this valve body out of a solid block of copper, and it literally took them about 6 months to machine it. And when they were all done, literally 90% of the material was in chips on the floor from this very elaborate. And we partnered with another 3D printing company. They literally printed us a sand mold for that casting, and we were able to take that sand mold, was in 7 different pieces that we had to glue the pieces together, but then could pour this very complex casting that with traditional molding techniques you could have never done, and save the Department of Energy thousands and thousands of dollars, and more importantly, the time. We did this whole thing in less than 6 weeks, which was taking them 6 months to do, and so that application of was one that really even kind of stretched our own imagination about what you could do with 3D printing.
Wow, that's amazing. Now, did that something you were pursuing, or was that something that they just chose you because of your background?
Well, I'm going to tell you it was a little bit of dumb luck in the sense that we were, sometimes you just have to be in a place where paths intersect. And we were at a trade show that was featuring our foundry at this particular trade show. We do a number of different trade shows during the year. And there was a scientist from the Department of Energy that happened to be at that trade show and came across us and just we've got very engaging salespeople and they started talking and again I'm thankful to the fact that our own salespeople, who are very technically oriented also, saw the possibilities in engaging because we had never what we did for them, we had never done ourselves before. So it's not like we could look at them and say, oh yeah, we do that every day. Here, just, give us the drawings and we got you covered. Had to convince them that we were a company, a group of people, more importantly, that we could work together to try to figure this problem out. And so it was really that when I say the dumb luck part was the fact that the right person was at the place that we were at, this trade show, and that we could engage them, and that they were willing to take some risks, and we were willing to take some risks to try to figure it out. Now, once I don't know that I would want to build my whole company on dumb luck, but the interesting thing is once you've had that opportunity, then all of a sudden it's not dumb luck anymore. Right. And you can really start to focus on, hey, where are other applications that look like this, that might be in need, where they're doing very, very complex machinings that a casting can get them there quicker and more costly. And there's still an extensive amount of finished machining that needs to be done. But if you could literally imagine about a 2.5 foot cube of copper being whittled down into a valve body, there's a lot of that isn't about the criticalness of a machine surface. It's just getting the shape. And of course the casting does that for them.
Right. Yeah. That's something that I think we've kind of gotten away from because we didn't understand it, especially a lot in the applications when it comes to any kind of casting. That was such a black art that there's so few people that really understand casting now that there's more opportunities for that because we've just kind of lost it and don't know how to get back to that point because, again, the people have retired, the businesses don't exist because everybody kind of got out of that business. Even the automotive, who used to have and run their own foundries, most of them started getting out of it.
Yeah, as a matter of fact, I mean, when I was my few years at General Motors and I was in the purchasing department and actually was buying cast irons, and most of the cast iron I was buying at Hydra-matic as a buyer was coming from a sister division, the Central Foundry division of GM also. So I'm buying from ourselves. Absolutely.
Right. If you had to pick another thing besides automation, what other key items do you see changing as we look forward in the destiny of manufacturing for 5 years out?
I think the tied to our ERP systems and is going to continue to advance. I think that the applications of ERP and are going to become more user friendly than they've been in the past, to allow smaller and medium sized manufacturers that might be doing more discrete type of manufacturing. Often the ERP systems were very much geared towards high volume types of manufacturing applications, and when more discrete style manufacturers who tried to adopt those things. There was just a lot of overhead costs in those ERP systems that you couldn't really get the benefit out of. And I think the folks on that side of the equation that are developing that software for manufacturers are a lot more sensitive to the small and the medium sized manufacturers and discrete manufacturers, so that they don't have all, because if I can take 10 hours of labor out of my product as an example, but I got to put 20 hours into it, back into the product and overhead because of this IT department I have, it's hardly worth it. And I think a little bit of that balance got out of whack, and now it's moving in the right direction. And again, on the soft side, I do believe that this apprenticeship model of learning and training and talent development is going to become a real and powerful thing again in as short as the next 5 years.
Great. Well, Bob, thank you so much for being here. I really appreciate you taking time out of your schedule and your busy day. It's made such a difference, I'm sure, for all of our listeners, and will continue to make an impact. I really do appreciate that. And as we move closer to FabTech, we'll probably see you up there.
Excellent. I'm looking forward to it, and thank you for the opportunity.
Thank you so much, sir. Again, this has been the Destiny of Manufacturing podcast. I've had Bob Roth on here from Roman Manufacturing. And everybody go out and have a great day.